This lesson is going to cover the difference between rational and irrational numbers. So let's go ahead and look at some definitions. Rational numbers are numbers that can be written as a fraction. Now, how do I know that? Remember, when you see the word rational, it has the word ratio in it, and ratio means fraction. When we look at the word irrational, ir means not, and ratio means fraction. So when we see the word irrational, we're looking for numbers that are not written as a fraction or cannot be written as a fraction. Now you might ask yourself, well, how do I know if a number can be written as a fraction? Remember our last lesson when we talked about things that can be written as fractions are decimals that terminate. So if we're looking at examples of that, that might be 0.35 or 0.2 or 0.1. We can also have decimals that repeat. So we know fractions or decimals that repeat can be written as fractions. So 0.3 repeating can be written as a fraction 3/9. So decimals that repeat are also rational because they can be written as fractions. Whole numbers are rational because I can write the whole number 2 as 2/1. Some negative numbers are also rational. -3 can be written as -3/1. Now let's talk about some things that are not rational or irrational, things that cannot be written as a fraction. One thing that cannot be written as a fraction, and our most common irrational number, is the number pi. Remember, pi is written as 3.1415, and it continues on. Because it does not terminate and because it does not repeat, that decimal cannot be written as a fraction. Some other numbers that are irrational are square roots of non-perfect numbers. So square root of 21, let's take a second and look at our scientific calculator. If I look at the square root of 21, clear it all, square root of 21, you'll see that it goes to 4.582575695, and that does not have any repeating. That so no repeats, no end. So that is irrational. Now please do not be fooled. There are specific square roots that are rational. For example, square root of 25. The square root of 25, let's just calculate it. Hopefully you already know what it is, but if you don't, you'll see that it's equal to 5. So the square root of 25 is 5, and 5 can be written as a fraction as 5/1. So I'm looking for things that are, so rational numbers can be written as a fraction even if they're in disguise. These type of things might be in disguise. One last thing, if you have pi divided by 2, now I know I said can be written as a fraction, but if a fraction ever has pi in it, we are going to say that it is irrational, because if we typed it into our calculator, that's equal to a decimal that does not stop and does not repeat. So let's determine whether the following numbers are rational or irrational. 1/6, it's a fraction, so it is rational. 3.25 repeating. Well, can I write it as a fraction? Yes, I can. 3 and 25 over 99. That can be written as a fraction, so rational. Pi over 2, we just talked about this. If anything ever includes pi, it automatically goes in the irrational category because it cannot be simplified to be written as a fraction without the number pi. 12.56789 all repeating. Is that rational or irrational? Well, 12, 5, 6, 7, 8, 9 all over. There's 5 digits, so 9999. That can be written as a fraction, so this is rational. Square root of 4. If I type it in my calculator, which is what I'm going to do to test it out, square root of 4 is 2. That is a whole number. 2 can be written as a fraction, 2 over 1. So this is rational. Square root of 2, let's test that out. Clear square root of 2. You can see it's 1.414213562, and it does not repeat and it does not terminate. So this is irrational. Okay, take a second, pause the video, and try this next page on your own. All right, let's calculate if these are rational or irrational. I see the number pi, automatically irrational. Something that repeats, automatically rational. Square root of -2. Well, now we have a -1.41 that continues going on in a random pattern. Okay, it's not a whole number, so irrational. I cannot spell today. 5.615347, and it continues on. Those ... means that it continues on. So it does not terminate. There's no end, and it does not repeat. There's no repeat to this pattern. So irrational. Square root of 1. Square root of 1 equals 1, and that can be written as a fraction, 1 over 1, so rational. And last but not least, -1/3 is already written as a fraction, so rational. If you have any questions, please reach out to your teacher.